So there's the level. It's not too high. That's a 1.5 liter bottle, and let's say 1 liter or something like that, maybe 700 milliliters were in it. This has a rubber inside. Maybe the pressure will be lost here also. You might not have pressure here if you don't tighten up well this. So there is no water here in the bubbler yet, and there is no sodium hydroxide in the machine either, and it's not doing anything. No pressure and no amp consumption. Plus the water line is pretty low. There is no pressure in this manner. So that's potassium hydroxide, and this is almost instantly dissolved. It's there at the bottom. And there is no more, so it was dissolved. I added that KOH stuff, and the amperage is still low, pressure is almost zero, but if I insert the tip into water, there is a little bit of gas, but not much at all. Now it's completely opened. Now you have little bubbles, and it pauses. Very little amperage. Okay, so I removed the liquid once again. Water line is invisible. Let's add a larger piece this time. That one. Let's see what happens. It's dissolved very quickly. The water is white. When there is little water in it, currently the line is invisible because the liquid is there, the machine is much more silent. When you add more water to it, it becomes louder. Now I added less water into it. Only that much is on the bottom of this bottle, and the water level because of that is not here at the top but down there. So a small quantity makes a large difference over here. And it's louder. It has more water, it's louder. The amp is still not increasing. And finally it reached the 1 amp mark. The pressure is still very low. So with that small amount of 1 amps, the pressure is increasing very slowly. But at least it's doing something. And after a while, when the pressure reaches to a certain level, the whole device should stop and the amperage should drop. Okay, so it turned off. The amperage is almost at zero. but it is at that level even when it's turned off. And the pressure is 1.5 kilograms per centimeter square. That has to be bar, 1.5 bar. So if I release the gas, then the pressure drops and the machine should turn on. The bubbler is making the noise. And yes, the device is on. So if you fully open it, you empty it, at least at that amp consumption. Okay, so here's a flame source. And let's open this one and see what happens. It's not on fire. Yes, we have a flame. Is that visible? There is a tiny flame. Let's open it up. Pressure is dropping. It's closed. There is no flame now. And it is a bit warm. We definitely need to increase the amp consumption. So this handle is broken. Let's see, will it melt it or not? I can see water on it. It smells like ozone. It's not melting it. Okay, after a little bit of time, it's got pretty warm. Ouch! Top part is very hot. So the flame is so small that you cannot see it, but this thick matter is untouchable. It should turn off around now at 1.5 bar. Yes, and it turned off. So although it's on 0 here, there is still pressure here. If you are igniting the gas here at the tip, then you get a flame. If you are igniting the gas inside the water, then it's an explosion. I mean, after it gets out of the water. Here we have this piece of metal. Top portion is broken. And of course this tiny flame will not do anything to such a huge piece of metal. The heat will dissipate in the entire metal and it will not melt. But let's give it a try. Let's see what will happen. Yes, there is a flame. Probably is not visible. The tip is a little bit bright. But let's apply it. Let's see where that crack is. And let's open up the valve. It's bubbling. I can see water. Oops, I opened it too quickly and it went out. It's warm already. Of course it's not melting. Now let's open it. The flame is larger. The metal is getting wetter. And I hear bubbles inside the bubbler and the machine will turn on. I'm opening it even more. This will not do anything. It cannot melt such a huge metal. And the machine is on. It's blasting the air onto me. The flame is smaller. It has some fan inside and I can feel that air. The flame might turn off because the pressure is pretty low and it cannot regenerate that gas in such a short amount of time. Let's see what will happen, if it will go out totally or not. Currently we have a little bit of flame there, so as you can see it is not melting anything, but it's definitely hot. The metal will heat up, you cannot put your hand onto it, although it is pretty thick, it will heat up. So the flame is 2800 degrees Celsius, around that number, and we still have a flame, still have a little bit of pressure. Let's see what will happen if the pressure goes totally down. It's consuming around 1 amp only. If I open it up more, then it will the pressure will drop even faster. Let's open it up even more. The flame is slightly bigger, pressure is dropping, it's getting smaller. So I totally opened it, I cannot go further anymore. And I still have flame, there is something. I'm not sure what, it's burning it, I can smell it. Okay, so this metal is that hot that I cannot touch it, I think. I can feel the heat rising up even here. So the pressure is interesting, but it's on zero and we still have a flame. Another thing, if you use a much smaller metal, not a huge one as this one, then the metal will glow, it will heat up so much that it will blind you, it will melt, but that's not a welding. That molten metal will not hold together, it will break. Another thing is that we still have flame here. So although the pressure is zero for a long time, we still have flame. That's enough for this. Let's just close it. You don't really need a bubbler for this because the flame, let's see the temperature. I can touch it. Okay, the tip is hotter. It's not too hot, but this might be very hot. It's warm here. Whoa, it's getting too hot over there. I don't have the courage to touch it over there. So the pressure is increasing. It's on half a bar. Here we have a wire brush that is very thin, so that should be nice. By the way, the device is barely consuming any power. That power meter, a mechanical one, is barely turning. We have a flame. Now this will blind us. As you can see, the metal is already glowing. Where is that wire? There's the wire. Okay, and it is red just by touching it. And we have sparks. So it is melting. We are melting metal. Flame is very small. I can increase it. Where's the metal? Watch your eyes. So that is glowing metal. Where's that metal? There's that metal. Another metal. There are blobs, metal blobs. If you put it further away, it's not that hot. If you put it closer, it's glowing much better. So around half a centimeter and you have that much light. At 1 millimeter you have more light. And if it's touching it, it's melting it. Okay, so that's the thin metal wire, more exactly. Now let's try a larger one, a screw. Now you can see the length of the flame also. The metal is coloring it. Okay, let's put it directly on. And it's red hot. This might generate some sparks. The machine is on. It's not making sparks yet. Whoa, it's glowing. If you put it very close, it's kind of blinding. Let's put it this way. The flame is smaller now. We don't have enough pressure, I think. Now it's not getting red. Now I placed it lower and now it's red. So can we melt a screw or not? The screw might be too thick for it. Now here we have an aluminium wire. Let's see how will it melt this one. This has around 2 or 3 millimeters. Oh, it smells. It's stinky. Now that is hot. It's red. It's not melting. Whoa, it's melting. So if the flame is large enough, then the aluminium is melting. And the flame is smaller, and the aluminium is not red anymore. So flame size should be bigger. So that happened to the aluminium wire. And it did welded together. Now that's a nice surprise. So you can weld aluminium. So as you can see, it is welded. You can weld aluminium with this machine. You can weld aluminium. Now here we have two nails. That's melting the iron. And I think that's a yes. I'm not sure. It's making sparks. It's blinding. And the pressure is dropping. The pressure is too low. Okay, so let's see what happened to the nails. I cooled them off using water and nothing. The nails are not melted together. And as you can see, something melted there or not, but the nails did not melt it together. There was some heat. The decoloration is there. Now here we have a small copper wire. It's red, it stinks. It's making sparks. And I think it's in one blob. Cool it down. So this did not weld it together. You can see the pieces here, but it also has that enamel, so I should repeat the process again with this one removed totally. And that was fast. And so it's better, much better, but it's not perfect. Now let's dip the end into a little bit of phosphoric acid. Let's see if it will do something good or not. The acid is burning away. It's making fumes. Okay, so we have a blob already. Of course it's very thin, and not the blob was damaged, but it cut off from before, so it might be good. The blob looks pretty solid. The blob is definitely strong, but it's not clean at all. Third attempt, no phosphoric acid on it. Oops, molten metal all over the place. It made a hole. Use at least a paper. Nothing. So I did not have any success with copper. That does not mean that others should not have any success with it. Now some simple ordinary wire. Oops, here are some goggles. And no, it's not good. It's like dust. Now here we have this one. Wow, it's nice. Wow, I created a hole. You can make holes with it. Another hole. So on thin sheet metal, it burns a hole right through. Can I touch it? It's not large enough. It's not large enough to pass through, but there are definitely holes. Now here we have this metal. Let's see if I can join the two ends together. I cannot see anything. The light is too bright. Okay, so even this requires a welder's mask. The light is way too powerful. Let's see, can I cut it off in a line? Yes, you can cut with it. Of course, this is a very thin metal, far less than 1 millimeter. I'm not sure, half a millimeter, 1/3, 1/4 of a millimeter, but you can cut with it. Now let's try another thing. Turn off the machine and let's see if I fire it up, because there is pressure inside. If I fire it up, what will happen with the flame? Of course it will go off, but let's see if there will be a flashback inside the bubbler and inside the hose, or the flame will go out here at the tip. So there's the flame. It went out just because I gave it too high pressure. So if the pressure is too high, the flame will also go out. I mean the speed, flame size, if it's too high. We can hear the bubbles. We still have flame. Will there be any flashback inside the hose, or it will go out here? The pressure is decreasing. The machine will not power on. Yes, now it should turn on, but it cannot because it's turned off from the button. We still have flame. Pressure is less than half a bar. The flame is very small. Pressure is not yet zero. The tip is red. Probably it's dirty. Here it's warm already. I cannot see the flame size with my own eye. And it starts fading. There is still light. Let's put it down. I don't see any glow there. It's completely opened. It's already cooler, so it has to be off. So nothing happens, at least it did not happen now, if the pressure is too low. No pressure here either.